Assalamualaikum warahmatullahi wabarakatuh. Welcome to another video lesson for physics, and this is week number 7. And for week number 7, we're going to continue this chapter. We are still in chapter number 26, which is radioactivity. We're going to continue and talk about the dangers of radioactivity, or in other words, the hazards of radioactivity. And then afterwards, we're going to talk about the how to safely handle radioactive substances, so dangers and safety for this topic. Previously, we learned about the uses of radioactivity, so you now know that radioactivity can be useful, but it can also be dangerous. It can also be harmful to our body. So let's start. Radioactivity can damage your cells, as you can see in this picture here. You can see these are victims of what we call radioactive burns. How does radioactivity harm you? Using two ways. There are two ways for radioactivity to harm you. Number one, due to ionization when the radiation passes. So ionization can be bad when there's too much of it, because you remember ionization is when an atom becomes an ion. So the atom changes and becomes an ion. This is especially bad when radioactivity hits your cells. The atoms of your cells can be ionized, and therefore that can change the atom into an ion, and therefore that can change the atoms in your cells into something else. So that can damage the cell, or it can mutate the cell into into something else. And when your cells mutate, that can cause cancer. Okay. And number two, due to heat of high levels of radiation, this is true for gamma rays. So I'll talk more about that later. So we're going to look at each of the types of radioactive emission, alpha, beta, and gamma, and see why are they dangerous. So alpha particles first. Alpha particles are slow, have short range in air, and can be stopped by a sheet of paper. Therefore, you think that it's not very dangerous, right? So it's slow, it doesn't travel far, and it can be stopped by a piece of paper. So it's safe, right? That is wrong. Okay, that is wrong. Whilst they cannot protect your skin, they cannot penetrate your skin. They can be harmful if they go inside your body. So if an alpha particle is outside, or alpha radiation is outside your body, it's safe, so it doesn't harm you that much. It cannot penetrate your skin. But if you accidentally eat a source of alpha particle, or a source of alpha radiation, and that can cause damage inside your body. For instance, if you accidentally eat or drink something contaminated with an alpha source inside your body, the alpha particles can ionize the atoms in the nearby cells. This can damage your cell's DNA, and it may turn cancerous. So it can give you cancer because of its ionizing capabilities. So if you remember, when it comes to the three radioactive types, alpha, beta, and gamma, alpha is the most ionizing. That's why it can ionize your atoms in your cells. Right? And that's why you never eat in the lab, because it can be contaminated with radioactive substances. You never know. Okay. Thus, alpha particles can be the most dangerous because they ionize so strongly. Now, beta particles. Beta particles have a longer range than alpha particles, but doesn't ionize that much, with the result that they do around 5% of the damage done by the same dose of alpha radiation. So when it comes to ionization, they're not really that strong, but they are a bit more penetrating, so they're a bit more dangerous. However, they do have more penetrating power, so this is what I said just now, which means that they can get through your skin and affect the cells inside of you. Now, gamma rays. Gamma rays hardly ionize atoms at all, so they do not cause direct damage in this way. However, gamma rays are very difficult to block. You require lead or concrete shielding to keep you safe from them. When they are absorbed by an atom, that atom gains quite a bit of energy and may then emit other particles. If that atom is in one of your cells, this is not good. So gamma rays are dangerous because they can heat up the atoms in your body. And gamma rays can cause radioactive burns because it heats up the cells in your body. If you remember, gamma rays, they are not particles, they are waves of energy. And because they are waves of energy, when it hits your body or it hits the atoms in your body, it will give energy to the atom. The atom will then be more energetic and therefore will produce more heat, and that's where the heat comes from. Okay. Now, how do you stay safe from radioactivity? These are the safety precautions. To prevent overexposure to radiation or any accidents, the following precautions need to be taken. Number one, workers working with gamma radiation must wear film badges or pocket dose meters in order to keep track of the dosage they are exposed to. So there's a typo there. So that shouldn't be. There's a typo there. It should be this one, tracked. Okay. Make sure you change that in your notes. To keep you safe and also to make sure you can monitor the levels of radioactivity in the room, some radioactive scientists, they use these badges, and these badges, they are colored, I think, black. And if the color changes, that means that there is radioactivity in the room and it's dangerous, and therefore you need to get out. Okay, so they use these badges to indicate if there is strong radioactivity or not. Number two, radioactive sources must always be stored in containers lined with lead. Walls of storage rooms must also be built with lead bricks. All rooms must be properly labeled. So everything must be covered in lead. So the room has to be inside the walls has to be there has to be a layer of lead, and also the container has to be uh, there has to be lead inside the container in order to protect so that the radioactivity doesn't go out from the container and the room. The radioactive The radiation symbol must be displayed whenever an experiment with a radioactive source is conducted. Okay, so that's just to tell everyone that you're handling radioactive substances, so no one can come close, and everyone needs to be careful of it. Number four, those who handle or in direct contact with radioactive materials should wear protective clothing such as lead-lined suits, like the one here shown in the picture, as well as lead-lined gloves. Tweezers must be used to pick up strong sources. So if you know what tweezers are, those are like pangapit, in order to pick up the radioactive substances. Now these suits, as you know, lead is a type of metal and it's quite heavy. So if you are wearing these suits are very heavy actually because it's covered with lead, so it's heavy. Number five, food and drinks are strictly prohibited during any radioactivity experiment. Otherwise, radioactive dust may be taken into the body together with the food. Okay, so no eating and drinking in the lab. Right, so that is all for this lesson. It's quite a short one. So don't forget to do your homework. I will be seeing most of you soon after Raya. Probably the school will reopen sometime in June. So do not forget to do your homework during the holidays. Until then, stay safe. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.